車の角を曲がればまだ君が待ってる日がした琥珀色のホテルだ言えなかったたった一言好きなよって胸の奥で夕焼けより熱く叫んでた琥珀色の放課後よ終わらないでと願って日々より止めたら変わっていたかなあの影に触れたくてПоговори со мной, хоть шепотом, хоть во сне. Я рядом, почти касаясь твоей тени на стене. Я чувствую, как дрожишь, когда смотришь в пол. Скажи мне все, что болит, я вынесу этот груз вновь. Поговори со мной, я рядом, я тебя хочу обнять, чтоб твой разбитый покой тихо смог удержать. Поговори со мной, я рядом, пока не уснет печаль. Я тебя хочу обнять, я тебя хочу оставить только в своей семье. Спрячешь лицо в руках и скажешь позже, не сейчас. Но время, как теплый чай, остынет, не дождавшись нас. Я пальцами по щеке нарисую новый день. Там, где ты улыбаешься, и слова найти не лень. Поговори со мной, я рядом, я тебя хочу обнять. An influenza, poxa, upon you, sirs. Pack a polytossers, a tissue. Bless my spirits a leaving. Poxa, upon you, sirs. Pack a polytossers, goose and tight. Bless my spirits a leaving. Close your windows, close your doors, unnatural breezy blowing on the air. Close your windows, close your doors, unnatural breezy blowing on the air. Inject to breed bugs in the blood and influenza. Inject to breed bugs in the blood and influenza. Poxa, upon you, sirs. Pack a polytossers, a tissue. Bless my spirits a leaving. Poxa, upon you, sirs. Pack a polytossers, goose and tight. Bless my spirits a leaving. Close your windows, close your doors, unnatural breeze. half a man. Attitude, confidence, God complete. Before I became half a man, I had a great personality. In the army, putting lasting knots. Real men's real green army. Before I became half a man, Dada taught me to karate. Before I became half a man, I could kick you up in Jacksie. Can't shoot 'em up like Clint Eastwood.
today we're going to be taking a deep dive into something pretty cool.
Yeah.
Using large language models,
Yeah.
LLMs, for software development.
Right.
You're probably already using these things in your work already.
Sure.
But we're focusing on a new approach that's all about managing context.
Mm-hmm.
Think of it this way.
Okay.
Like, we're giving LLMs a roadmap instead of just saying, go explore.
Yeah.
Yeah.
That's a great way to put it.
Yeah.
LLMs have incredible potential, but they can kind of get lost without clear instructions, and a solid understanding of the big picture.
Yeah, that's one of the biggest challenges that developers face with these things.
Absolutely.
They can be a bit forgetful.
Yeah.
You give them a bunch of instructions, but then they start suggesting code that's totally irrelevant to the task at hand.
Right.
It's like they have short-term memory loss.
They do, yeah. Maintaining context is key.
Yeah.
It's like asking a chef to make food. You'll get something, but it might not be what you had in mind.
Yeah.
You got to be super specific with your instructions and keep the LLM focused on the task at hand.
Okay, so...
That's where this idea of context-aware LLM interaction comes in.
Okay, so how do we make this context thing explicit?
Right.
Our sources talk about something called .popt file.
Yeah, .popt file.
It sounds like they're the secret sauce here.
Yeah, so imagine you're building a house.
Okay.
Each room has a specific purpose, right?
Right.
You wouldn't use a hammer in the bathroom.
Right.
Or a toothbrush in the kitchen.
Yeah.
So these .popt files are like instruction manuals.
Okay.
Attached to each room or module of your code.
Okay.
They tell the LM exactly what that code is supposed to do and how it fits into the overall project.
That's a great analogy.
Thanks.
Our sources actually use a flashcard app as a real-world example.
Right.
So you might have one .prpt file that tells the LLM, how to generate the data for the flashcards, like the term and definition, and another one for creating image descriptions based on that data.
Exactly.
Okay.
By dividing the project into smaller, well-defined contexts, we can make sure that the LLM stays on track and generates code that is both accurate and relevant.
Okay, so it seems like this is great for organization, for accuracy.
Yeah.
Are there other benefits to this approach for developers?
Well, effective prompt management is crucial for scaling LLM use in software development.
Okay.
So think of the prompt manager as an air traffic controller.
Okay.
It directs the flow of information between LLMs and different parts of the project.
Right.
It's preventing conflicting instructions and promoting reusability.
Okay.
This not only helps avoid errors, but also saves a ton of time and effort in the long run.
So instead of reinventing the wheel every time, we can reuse prompts and contexts for similar tasks.
Exactly.
Okay.
Yep.
That's pretty efficient.
It is.
And this brings up something that really caught my eye.
Yeah. Okay. While I was digging into the source material, it seems like prompts are kind of evolving beyond simple text.
Right.
They're becoming more like code.
Yeah, it's fascinating.
Yeah.
We're starting to treat prompts as a form of programming instruction.
Interesting.
Well-designed prompts, just like well-written code, should be modular, reusable, and easy to understand.
Okay.
This shift towards prompts as code has huge implications for how we think about software development and the role of LLMs.
I'm seeing a parallel here.
Okay.
Just like we break down complex software into smaller modules, we're now doing the same with prompts.
Exactly.
Right. That's a good observation.
It's like those cooking shows where they break down a complex dish into manageable steps.
Yeah.
You've got your ingredients,
They're variables.
the steps, the instructions,
Yes, right.
and a specific output, the delicious dish, or in our case, the working code.
The code, yeah. It's a great way to visualize it.
So we've talked a lot about instructions and context.
Right.
But what about the output?
Right.
Where does all the text, the code, the data generated by the LLM actually go?
That's a great question.
Yeah.
So you've given the LLM its instructions and context, but what happens to the output?
Yeah.
Think of it this way.
Okay.
You wouldn't write a novel and just leave it scattered on scraps of paper, right?
You'd want to organize it, refine it.
Right.
Maybe store it somewhere safe.
Exactly.
That makes sense?
So how do we handle all the data that the LLM generates?
Yeah, how do we do that?
Well, the source material starts with a simple approach.
Okay.
Using in-memory storage.
Okay.
Think of it as a temporary notepad where you jot down ideas, quick and easy for initial prototyping.
Okay, so for smaller tasks
Right.
or when we're just experimenting, in-memory storage works fine.
It's a good starting point.
But what happens when our projects get bigger and more complex?
That's where more robust solutions come into play.
Okay.
As your project grows, you'll need to think about storing the LLM's output in files or even databases.
Okay.
This ensures you don't lose valuable data and allows for easier management and retrieval later on.
Got it. So we've broken down our project,
Right.
given our LLMs clear instructions, and figured out how to store the output. But how does this all come together in practice?
Right.
Our sources use this really cool concept called prompt chaining.
Yeah, prompt chaining.
To illustrate the workflow.
That's where things get really interesting.
Yeah.
Imagine a chain reaction where the output of one prompt triggers the next.
Okay.
Creating a sophisticated multi-step process. And all of this is guided by those all-important .prpt files.
I'm picturing a domino effect.
Okay.
With each domino representing a stage in the process.
Right.
And the .prpt files act like the carefully placed guides that ensure the dominoes fall in the right sequence.
That's a great visualization.
Let's go back to the flashcard app example.
Okay, yeah.
The first prompt might generate the basic data for a flashcard.
Right.
Including an image idea field.
An image idea field.
Then a second prompt takes that image idea and uses it to craft a detailed description for an image generation tool.
Exactly.
So the first prompt sets things in motion.
That's it.
And then the second prompt picks up where the first one left off.
Yeah.
Building on the existing context.
Building on the context.
It's a seamless flow of information.
Exactly. And this chaining can continue for as many steps as needed.
Wow.
Allowing for complex workflows that are still guided by the context provided in the .prpt files.
Okay, I think I'm getting the big picture here.
Good.
But let's zoom in a bit.
Okay.
And talk about the .prpt files themselves.
Right.
What exactly do they look like?
So a .prpt file is essentially a structured document that provides the LLM with the context it needs for a specific module or task.
Okay.
Our sources suggest using a simple, human-readable format, like YAML, or even plain text.
So no need for complex coding languages or cryptic syntax.
Exactly. The key is to be consistent.
Okay.
And structure the information in a way that the LLM can easily understand.
I'm imagining it as a set of clear instructions written in plain English. Almost like a checklist for the LLM.
That's a good way to think about it.
A well-written .prpt file should include things like the purpose of the module,
the purpose,
the data fields it needs to generate,
the data fields,
any specific formatting requirements, and the desired output format. Okay, that makes sense.
It's like a blueprint.
But with all these .prpt files for different modules and tasks, things could get pretty disorganized.
Yeah, for sure.
How do we manage them all?
Right.
How do we make sure the right .prpt file is being used at the right time?
That's where the prompt manager comes in.
Okay, the prompt manager.
Think of it as a conductor of an orchestra.
Okay.
It keeps all the .prpt files organized, loads them as needed, and makes sure the LLM has access to the right context at each step of the development process.
So the prompt manager takes on the role of a project manager.
Exactly.
Making sure everything runs smoothly and efficiently.
Smoothly and efficiently, that's the goal.
Okay.
The prompt manager also handles things like variable substitution.
Oh, right. Variable substitution.
Remember those placeholders in our prompts?
Yeah.
Like the number of flashcards or the topic?
Yeah, those variables that allow us to customize the prompts for different scenarios.
The prompt manager takes care of replacing those placeholders with the actual values when it feeds the prompt to the LLM.
Right.
This level of automation saves time and reduces the risk of errors.
Okay, it sounds like the prompt manager does a lot of heavy lifting.
It does.
Keeping track of everything.
Keeps everything organized.
And making sure the LLM has what it needs to succeed.
That's right.
But I'm still a bit fuzzy on the actual workflow.
Okay.
Can we walk through an example?
Sure.
Let's stick with our trusty flashcard app.
Okay, yeah.
Imagine you want to generate image descriptions for a set of flashcards.
All right, so we have a specific task in mind.
Okay.
You'd have a .poct file specifically for that image description module.
Got it.
This file would outline the purpose of the module, the input it expects, like the image idea text, and the format of the output, which would be a detailed image description.
Okay, so we've defined what we want the LLM to do,
right,
and what kind of output we expect.
That's the first step.
What's the next step?
You invoke the prompt manager,
Okay.
telling it which module you want to use.
Like,
in this case, the image description module, and providing any necessary variables, like the image idea text for each flashcard.
So the prompt manager knows which module to use,
right,
and what data to feed it.
Exactly.
What happens then?
The prompt manager retrieves the appropriate .purpt file,
Okay.
loads the image description prompt,
Welcome back to The Deep Dive. It is Sunday, February 1st, 2026. And today, we are talking about Ralph Wiggum. And no, I don't mean the kid from The Simpsons who, eats paste and says, "I'm helping."
Although...
Well, actually, I kind of do mean him. Because somehow, in the software world of early 2026, Ralph Wiggum has become the dominant coding pattern.
It sounds like a total joke, doesn't it? But if you really look at the landscape, I mean, Ralph is basically the employee of the month.
It's just...
Yeah.
It's so different from where we were, a year ago? I remember 2024, 2025, we were all in this era of vibe coding.
Okay, so for the last couple of years, right, we've all gotten pretty used to AI as a coding assistant. But that's all about to change. Seriously, the way we use AI to write software is going through this fundamental revolution, and it's moving way beyond simple code completion. Think about it like this. Your AI coding buddy is getting a massive promotion. We're moving away from the AI as, a junior pair programmer, the kind that needs you looking over its shoulder constantly. The new model? It's AI as an autonomous agent, a senior dev you can just hand a task list to, go grab a coffee, and come back to find the work actually done. And listen, this isn't just a tiny step up. As Deepak Singh over at AWS puts it, we're graduating from AI being just a glorified typer, basically a fancy autocomplete. We are now walking into an era of what you could call goal-seeking collaborators. These are agents that can reason through problems, come up with their own plans, and then, just execute them. Okay, so for the last couple of years,
what is it that
right,
makes
we've
this
all
new
gotten
generation of
pretty used to
AI
as a
so
coding assistant.
different?
But that's all about to change. Seriously, the way we use AI to write software is going through this fundamental revolution, and it's moving way beyond simple code completion. Think about it like this. Your AI coding buddy is getting a massive promotion. We're moving away from the AI as, a junior pair programmer, the kind that needs you looking over its shoulder constantly. The new model? It's AI as an autonomous agent, a senior dev you can just hand a task list to, go grab a coffee, and come back to find the work actually done. And listen, this isn't just a tiny step up. As Deepak Singh over at AWS puts it, we're graduating from AI being just a glorified typer, basically a fancy autocomplete. We are now walking into an era of what you could call goal-seeking collaborators. These are agents that can reason through problems, come up with their own plans, and then, just execute them.
So what is it that makes this new generation of AI so different? Let's dig into the key concept that really defines these more powerful systems.
The big term you're going to hear everywhere is agentic AI. And here's the crucial part. These systems do way more than just react to a prompt. They're proactive. They can actually analyze a problem, map out a multi-step plan, and then go and carry out that plan, often with little to no help from you along the way. Okay, so how does this actually work in the real world? Well, one of the most popular patterns popping up has a pretty memorable name. It's called the Ralph Wiggum loop. And yes, I mean Ralph Wiggum from The Simpsons. But believe it or not, it's a surprisingly powerful way to get AI autonomy. And seriously, don't let that silly name fool you. As developer Matt Pocock points out, people are using this pattern for some really serious work. Everything from adding test coverage to building entire programming languages from scratch. It's a real-world technique that just unlocks a whole new level of leverage for developers. So what is it exactly? At its core, the Ralph Wiggum pattern is just an AI agent running in a continuous autonomous loop. You give it a list of tasks and a super clear definition of what done looks like. The agent then just chews through that list one task at a time without stopping until it finally hits that completion goal. The real magic of this loop is just how simple it is. In every single cycle, the agent reads the plan, figures out which task to do next, implements it, and then, and this is critical, it runs feedback loops, like tests or linting, to check its own work. After that, it commits the code and just starts the cycle all over again. The key difference here is the agent picks the next task, not you. Now, developers are using this pattern in two main ways. First, there's what's called human in the loop, or HITL. This is where you run one cycle at a time, you watch what it does, and you can step in if you need to. It's perfect for learning the system and dialing in your prompts. But once you trust it, you can go away from keyboard, or AFK, and just let the agent run totally unsupervised to handle all that bulk work, like refactoring or clearing out a backlog. Okay, so this new autonomous power, it's forcing a huge shift in what a developer's role even is. It's pushing us towards this methodology called spec-driven development, where our job becomes less about writing code and more about being an orchestrator. And this quote just nails it. The focus isn't on the nitty-gritty of writing code line by line anymore. Instead, the most valuable skill is becoming the ability to think systemically and to communicate high-level plan to your AI partner. So here's the bottom line with spec-driven development. The most important thing you create is no longer the code itself. It's the spec, or the spec. This document, written in plain English, describes what you want the code to do, and that becomes the source of truth that the AI agent uses to generate all the actual code. To make this a little more real, let's look at a tool called Kiro. Its whole workflow is built around 3 key documents. You've got a requirements doc with user stories, a design doc that explains how the solution will be built, and finally, a task list for the agent to just go and execute. See what's happening? The developer's job here is reviewing and approving these documents, not the code itself. Big shift. But of course, giving AI this much autonomy, well, it raises some pretty serious questions, especially for big companies. This isn't just a tech decision anymore. It's a whole conversation about business, risk, and governance. And that really brings us to the core question here. Just because we can give an AI this much freedom, should we? I mean, it's one thing to let an agent run wild on a personal project. It's a completely different ballgame when it's messing with a core business system. So when is it safe? And when is it just a huge liability? This table really lays out the fundamental trade-off. Going fully autonomous gives you maximum speed, for sure. But it also comes with a higher risk of things going wrong, especially in complex situations. The human-in-the-loop approach, on the other hand, is a bit slower, but it gives you more control, it helps with compliance, and frankly, it builds the trust your engineering teams need to actually rely on this stuff. So, when is human oversight an absolute must? Well, definitely in regulated industries like finance or healthcare, any customer-facing apps where a bug could damage your brand, and for sure, any security-sensitive code. Oh, and for your core enterprise platforms, keeping a human in the loop is pretty much essential if you want to maintain any kind of long-term architectural sanity. But on the flip side, full autonomy is a perfect fit for tasks that are low risk and super repetitive. Think about generating test cases, refactoring code to match style guides, building internal tools that aren't mission critical, or running optimization tasks where you have a really clear metric for success. This is where you can safely unlock some massive efficiency gains. Okay, so if today is all about a single autonomous agent, the future is all about orchestration. We're talking about managing entire teams of specialized AI agents, all working together. This diagram here shows you exactly what that looks like. It's an agentic testing framework. So you can imagine one agent whose whole job is generating tests, another one that executes them, and a third one that analyzes the results to make the whole process better. It becomes this self-correcting loop where different AIs collaborate to constantly improve the software quality. Pretty cool. And the results? They are absolutely staggering. Some research shows that a standard one-shot LLM spit out tests that failed over 38% of the time. Ouch. But this multi-agent closed-loop system, it dropped that failure rate to under 15%. That's a 61.5% reduction in errors, which means way, way less cleanup work for human developers. So it's no surprise that a whole new category of tools is popping up to manage these AI teams. You've got things like Conductor and vibecoding that let you run multiple agents in parallel on different tasks. And then you have something like Gastown, which is designed to manage dozens, maybe even hundreds, of agents at a massive scale. But let's inject a little dose of reality here. This new world isn't all sunshine and rainbows. As Birgitta Bogler from ThoughtWorks points out after trying some of these spec-driven tools, the overhead can be huge. For smaller tasks, reviewing endless markdown files can feel like using a sledgehammer to crack a nut. A lot of developers would just, rather review the actual code.
And that leaves us with a really fascinating final question, doesn't it? As we shift from writing code to writing these detailed specifications for an AI to follow, the very nature of software development is changing right under our feet. The most important skill might not be implementation anymore, but clarification. So you have to wonder, is the future of coding not actually coding at all?
Yeah.